The problem of the week today
Okay.
is titled Correct Order of Comparison Data Table. So if we read it, I need to design a table where the user will have to approve. You ready?
Sure.
It's up to you now.
I'm ready. I was born ready. Thank you. Okay. So we met another friend who's working through a comparison use case, and their problem was around where people are approving new values and doing some comparison of old ones to new ones. As a reviewer of numerical data, because that's all we know about the use case, I need to spot any suspicious percentage difference so that I can take action. The word spot is really key to this problem because that implies how quick it needs to be. It needs to be almost without thinking. So when we looked at the as is, we thought about that rationale of like, how do we want to approach this problem in the first place? So some of the major themes that we were considering, this idea of percentage difference, it must be here for a reason. So what is that telling us? We were wondering about if the order really ties in with time. We also questioned the best way to visualize this information because being able to parse a difference is tough. Like it's actually really hard to do. And when you have really dense information, it's super challenging, even if you're a data analyst. We thought a lot about people get situated with data. We see a lot of dashboards where that's an issue and people are just seeing data out of context, and that's really hard to work with for our brains. So we thought about averages and thresholds. We thought about the role that AI can play. We thought about, just doing math based on historical data. These are all ways that we can situate people in a baseline. And we talked about flagging processes, especially in enterprise software, where you're not necessarily getting a definitive answer and you're stating this is weird. You're just maybe doing something that's part of another process. It's sent to somebody else. Our general approach to solving this problem is basically have progressive disclosure of information. So really consider how to disclose this information in a manageable way and add an interpretation layer and scanning optimization. So this thing in the problem of spot the suspicious thing, that is really key to having a good solution for this. So we started off thinking about a super, super minimal table view. Introducing the idea of status within this table could be a really nice way to give people a baseline and point them to things that maybe should be flagged. So we created this table here where for every item in the row, we have status, we have the new value being shown, the diff. The key thing that we introduced here was little tiny data visualization that kind of eyeball like what's been going on with this particular row. So we introduced that idea of spark lines and also just having a little bit less showing by default. So that's what you see here in this default state. We allow columns to be added and removed and the viewing to be modified in the way that the user will see fit. We also let you dive into the details and really scan the full data set. This table here where we have entries marked by a date, and then they have the value as well as the diff and any history that's already gone into this row, in addition to the interpretation layer. But basically, we just let people dive in, especially in the case where you don't need to do a bunch of comparison between row 125 and 126 and 127. You actually just need to go into this 125 row and investigate a little bit more. So that's what we came up with. So then the next steps, what we would do is like actually test the, get a little context and ask some users because, hey, they're pretty cool.
They're pretty cool. Oh, what happened when two designers enter a bar? They order a table. That's what we did.